So we're excited to present on our webinar today. And before we jump into the subject matter, I just wanted to take a quick second to introduce everyone to Alyce, let you know who or what she is and what it is we're talking about today. And then I will hand it over to our speakers. So Alyce.ai was developed in Object Computing's Innovation Lab to help companies automate and scale their AI efforts. Alyce is a predictive AI platform that converts subtle data patterns into actionable and scalable insights. One of the things that we'll be talking about through the journey of Alyce's inception is some of the myths that surround AI and some of the barriers that keep companies from adopting this revolutionary technology. And with that, it's my pleasure to introduce Jason Bull, VP of our machine learning practice.
Good afternoon, everyone. There's a couple of other speakers you're going to hear today. Just after me, Zhao Yang's going to talk. He's our Director of Machine Learning, and Tonya is going to wrap it up at the end, who is our Director of Business Development in Machine Learning as well. So you'll hear a couple of different voices. Not all of them will have a great Australian accent, so just bear with them. So the first thing we're addressing here, the first myth is all around, I need a lot of data. And like any good myth, there's always a grain of truth to it. And what we really see is a lot of times people we work with across a lot of different industries is, I'm not sure I've got enough data, or let's defer getting to an outcome until I pull all of the right data together. And what we found is that's not an optimal solution. And what we see over and over again is a repeating pattern, and that's what Zhao's going to go through with some illustrations here this afternoon. And the first piece is starting with a clear business outcome in mind, and really often a fairly simple business outcome that creates some value. Right-sizing the data. So often you don't need all of the data to answer the first simple question that can create some value. And then the third piece is having the right validation strategy, particularly if you're not dealing with all of the data and all of the circumstances, which you almost always aren't. You very rarely have a complete solution in terms of data with all the dimensionality, so that you can understand where it can be predictive and where not. So we find this repeating pattern extremely accelerating in terms of getting to business outcomes, and we're going to share some examples that illustrate it here this afternoon. So with that, I'll hand off to Zhao, who will walk us through some examples.
Okay, good afternoon, everyone. So how much data is really enough for your successful ML project? That's actually accounted for about half of the questions I got from a lot of the business leaders, a lot of the my fellow data scientists. So if you're like me as a data scientist, we actually learned a lot, from our academic training, from one of the very prominent, professors from Caltech, Yasser. And we were told that, hey, on average, as a rule of thumb, you need actually thousands of data points actually to do an average, machine learning projects. Okay, so on the other hand, we also actually, as a part of, the effort to sharpen our machine learning skills, we've been using some of the public data sets actually to practice, how we build our models. And one of the interesting examples, I'm pretty sure some of you, already actually used probably many times, really the very famous, handwriting, the 10 digits, recognition. And you are talking about, I have 70,000 data points. So every digit actually gonna have 6 or 7,000 images. Wow, that's very decent. And we lately, if we are looking into some of the machine learning, or deep learning examples, the ImageNet, so what we're told is really, hey, I need actually 10,000 images per class, to build a reasonable object, detection model. But is this actually really happening across different industries? So in many of the projects, machine learning project I carried out, I see, a lot of time, our business leaders, start off with a really fabulous, AI, strategy, but quickly they actually, realize, that, hey, the two kind of extreme, examples here. One is really, hey, wow, I don't have enough data. They are really, really put off by that. So this is actually kind of, in line with what, what is other, tech giants actually are, are seeing, like, IBM, Microsoft or Google. And in fact, from the latest, Harvard Business, review, it's actually published 2 days ago. It's actually estimated, actually, there are more than 3/4 of the companies actually are dealing with, building machine learning models with less data. So it is actually everywhere. The other extreme, which is, related to the buzzword, big data. Hey, I'm actually sitting in front of, a pile of, data, it's coming, all the time. I don't know what to do this. So for the two examples, is there any actually technical solution, out there can solve it? The answer is actually yes. And, so really, really, for the next, section, I'm gonna actually share, with 3 examples, examples with, very, very little, data, like 1 data points. Examples, with, hey, some data points, and then you have a lot of data points. Just try to show you that, how we actually think about solving those challenges actually differently, and how can you actually, through some of the, technical workarounds, plus, the core principles Jason mentioned, hey, the 3 basic principles together, how can you actually drive, to a much better, outcome, instead of, the frustrations you have to deal with, every day. So gonna start off with, my, 1 data point example. So last year, based on the feedbacks from our friends in the oil and gas industries, they're asking us to explore a technical solution, how to actually, build a smart, model to help them actually, to read, the different readings from the analog, which is actually very, very still widely used today across, utilities, oil, gas, and a lot of the manufacturing processes, So the challenge they are facing is really that, because this is the analog readings, and there are a lot of the human has to read it, from time to time. So a lot of time, actually, there are a lot of the human errors, So how can they get actually consistent readings? Always be a challenge. So how did we do it? So the solution we provided actually, started with 1 data point, so the solution is actually very general, meaning that it actually can work with, multiple type of, gauges. In fact, if you look at the industry, there are probably hundreds of, type of, the analog gauges. But for this particular example, we actually started with, an image on the left, which is, a pressure gauge, So this is the data point essentially we started with. But next step, what we did is actually, we actually can, if you look at the anatomy of this, kind of, gauge, it actually has 2 parts, your plate, the face really shows, the different potential readings, and, on the right is actually at the dial, where your dial stop actually going to give you the reading. So as part of the, the model training, we actually just, use, the face plus the dial, we actually can quickly generate, the different, readings, meaning the different unique image corresponding to the pressure rating, like, 2.1 psi, 3.5 psi, things like that. And based on that, that set of, the labels, the labeled images, we actually then, we did additional, images, additional simulations, generate a lot more images. This is actually, really the images we actually started feeding into, training that, deep learning model. So during the training process, there are additional actually, tricks we can play with. This is actually called the data augmentation. So this is where you can do, different, transformations about your simulated image. Like, you can shift, the frame of the picture. You actually can flip. You can flip your image. You can do actually, you can change, the aspect ratio of, image, meaning the different ways of zooming those. And of course, you can actually adjust the brightness of every picture. You can add additional noise on top of that. Those images really helped, us, to get to enough images, probably close to 1,000 image, as suggested by some of the industry, experts, So with that data set, we actually can really build a very robust, yet, very generic model, actually, with a good accuracy. This is actually, the process we actually went through. So with simulation, with data augmentation, and this is how we get to a good performing model. Okay. So in addition, we also actually build a validation framework, to help improve the model, performance. Yes, simulation is good. This is actually give us a quick route actually to demonstrate the value, first, meaning that, hey, we can build a working model. Still simulation based. So afterwards, we actually, deployed, this model, in cloud. This is where actually you, in a production environment, you actually can start, getting a lot more actually the real scenario images, and once you accumulate enough, this is where you can slowly swap out, your simulated image, and you slowly transition to a more kind of a production, relevant, model. And this is actually, you can do this, iteratively. This is really where, once you have actually a model you think is working, you have to actually pressure test, in a production environment. So really the takeaway is really that, for a problem like this, simulation really helps. It's actually can quickly get you to a usable model first. This is really for you to demonstrate value. And, the other takeaway is really the, once you have a model, you need to actually deploy that quickly, pressure test that. This is actually the foundation for you to iteratively actually improve your model performance. My second example is actually, the image-based, object, detection model, but with some data, meaning that, I don't have a lot, I don't have one, data points, but I'm kind of in the middle of, somewhere. And this is really the scenario we are talking about, so this is a part of the computer vision, field. Lately we have seen a lot of the clients actually being using, the image-based, those type of, models actually for different, for their different, product recommendations. There are actually a lot more applications like that. For example, people actually are using this to drive some of their product recommendations. Like, I see companies using the image-based, recommendation to recommend what type of clothing, for example, people would buy. So this is a really nice application. The other one is really the face recognition, every day, like, if you have an iPhone, probably you're using that, so the principles really applies here. Autonomous, driving, so this is actually, another application. The other piece is actually in agriculture, for example, using imagery, actually, you can build models like this to distinguish, hey, a crop, you really care, what is the weeds you want to kill. So, in a situation like that, I have some data. What do I do? In this particular example, suppose I want to actually build a model, to recommend, pet foods, to some, pet owners. I actually, the model I'm building is actually trying to actually detect, the subtle difference among, the three, very similar dog breeds, Brittany Spaniel, Columba Spaniel, and, Golden Retriever, so for each, dog breed, I have, a varying degree of, the data size. For example, the model actually struggles with, let's say, detecting, Brittany Spaniel and Columba, Spaniel, because I really don't have much, what should I do in this case? So of course, there are solutions available to solve a problem like this. So in a situation like that, so we can apply, transfer learning, and this actually should, quickly cut back, the number of, images you need, So transfer learning is actually a technique being around for many years, being actually getting, popular, in the deep learning kind of, community. So the idea is, we, using ImageNet, like, the tech giants like, Google, Microsoft, or, Amazon, they actually already build, those different, the general, object, detection, the deep learning models, like, inception, Xcepcion, those actually from, Google, or ResNet, from Microsoft, So if you actually, directly apply, those models, to the problem you're trying to solve here, your model actually gonna suck. That's what we learned. So really, in a lot of the situations like that, you have to actually custom build your own deep learning model. This is what we learned. So the way, we transfer learning work is really that, we can leverage, the existing, the architecture from those, pre-built models, because those models actually already captured, some of the geometry of, each image, but using our actually own images, this is where we actually can fine tune really some of the ways, from those pre-built models. This is actually the path for us to quickly get to, something reasonable. So the other piece is really the data augmentation strategies. So I mentioned kind of, some of the tweaks, you can make, related to data augmentation. You can do bounding box, you can actually flip, rotate, you can change the zooming kind of, nature of your pictures. Those actually the different, data augmentation techniques. Lately, there are some kind of, better actually, tools actually to make this better, meaning that, for any actually given data set, you actually can, by carefully actually building a augmentation, optimization algorithm, you actually can let your data to decide, among, let's say, the 4 or 5 tricks, from the data augmentation side, what is actually the best, what is actually the best combination of the few, strategies works best for you. So this is actually some of the latest research, really from, Google, I think, mid last year. And this is actually their algorithms, available. And we see the benefit of those, when you actually apply, apply the algorithm like this to the projects we've been working on. So what if you still actually get, a not so optimal model? So what do you do? situations do exist like this. So, and for a model like this, another way which we also work is really what I call the smart crowdsourcing. So this is actually the technique we call active learning, probably be around in the computer science domain for for quite a while, but lately has been gaining a lot of the traction just related to some of the real problems people are solving across industries. The idea is like this, so really that yes, for your deep learning projects, your AI project, you started with a small data set. But if you can quickly actually train a model with some level of accuracy, that's your starting point. And then you actually can apply a model like that to a lot of more images on the web or from other like ImageNet. So you actually can run through your model through a lot of the images out there. And in a sense that you can actually pre-label those images. And then you actually work with your subject matter experts to cross-validate those labels. And then this is actually where you can get to a lot more kind of the clean labeled images. So going through, and then you actually can retrain your model. This is actually another way proving being very effective iteratively. This is actually the cycle you can use actually to quickly improve your sample size, and you can get to actually a fairly predictive model quickly. Okay, and this is kind of in some ways this is a semi-supervised approach. Okay, so the takeaways here is really that transfer learning actually works. So it's we have a lot of actually use cases being proving that it works. Data augmentation, yes, you can start with some of the very basic ones, but there are ways actually to optimize, which strategy gonna works best. So it definitely helps, So the other one is really the active learning. Active learning actually can, accelerate, your model performance. And again, so don't forget that really, to really iteratively, improve your model, you have to actually, pressure test your model. My third example is related to the big data kind of, fields where my second frustration, the example I showed, I'm sitting in front of, a pile of data. What should I do? So it is intimidating, and, I don't know what to do with it. So big data being around for many, many years, there are quite a few examples out there, for example, like a video surveillance, you actually get images, terabytes, probably petabytes, on a daily basis, Cybersecurity, you have different, every company probably maintain, a security team where you have different firewalls, you have different devices, and you get a lot of the log data, from your computer systems, a lot of the data. Stock exchange, so New York Stock Exchange, so we're talking about, more than 2,000 stocks, every day the trading happens, all the time. So that's another type of, data. Facebook, every day people actually post the videos, images, share their opinions, so they have a lot of text, so those are actually the typical examples, for big data. So what are the solutions actually exist if you have a lot of data? The other interesting thing is really that, lately actually I've been seeing a lot of the tweets or, blogs about, this big data, so is it actually really that, so this is a few examples, so 10 years ago, it might be it was the buzzword, on the street. But today, so people apparently are getting frustrated with, a lot of data. So what do you do? So our experience working with big data, I think, still going back to Jason's, the three basic principles, if you actually can formulate, your business outcome first, that's probably already get you, halfway through your success, for, a big data related machine learning projects, so, and we've seen that actually for quite a few times, So here I'm showing a quick example, where, see, in a company, you have actually a sophisticated, actually firewall systems, kind of, for your cybersecurity. And, every day, actually, your log events from different firewall devices, coming in, in kind of, millisecond. And really, we are talking about a lot of data. So today, actually, we see a lot of the companies, especially like, the IT support team, the network team, they typically, because of, the too much data, they are mostly actually reactive to a lot of the network problems, instead of, kind of, manage this, more proactively. So, and, the downside of that is actually, you have to actually, spend a lot of money to maintain your support team, and people are busy, okay? So in a situation like this, how would you actually, formulate the outcome you want, namely how you want to actually use your data? So in a data set like this, monitoring, anomaly monitoring situation, you actually, what we did with one of our clients is actually, we started actually asking them, hey, what is actually, what is the most important, events you care? Because, obviously, your team, this is where actually your team gonna spend most of their time, handling those. Not that every actually anomalies actually matters, so equally. The second question you can think about this is really that, how much really resource, you spend on those, events. Is that actually 5 FTEs? Is that actually, 5 teams, 10 FTEs, so, and this is where you actually can know that, if you can predict, those most relevant, anomalies, what you would get, and better yet, if you can predict this ahead of, the events, you probably can even actually do a lot of, more things to manage, how do I actually, prevent, those events from happening in the future. So the other one is really that, just try to, manage your expectation. If my model, isn't, perfect, is it actually really still useful? Because I see a lot of the clients actually struggling with, oh, I need actually a perfect model, 100% actually to make, to believe, this is useful. But I think in a lot of time, actually, you don't need actually a 100%, accurate model. Maybe 70% actually going to be good enough for you to start, realizing value from, your pile of, data. So this is kind of, what we did, So on the technical side, there are kind of, peculiar ways to think about, how to handle, a lot of data in this case, So what we have learned is really that, as Jason mentioned, right-sizing your model in a way that you can see, the insight from your data, probably going to be, this is actually the most critical step actually in formulating and building your machine learning, model out of your big data. So what I'm showing here is really that, I have a lot of the log files, in real time, from my firewall devices, for example. And, so by carefully choosing, how I summarize my data, for example, I can look at, those, events, in a 1 hour window, 5 minutes window, or 3 hour window. That's actually gonna, give me about some ideas, just, how the, my network traffic pattern gonna looks like, on the left graph, this is actually show that, if I summarize the noise data, I have on the left, I can clearly actually see the pattern of, hey, at a certain time of the day, actually, my network traffic, does, spike, so this would give you a lot of insight on formulating, your machine learning problem. What are your pinpoints, in this case? This actually has been, very, very useful, So really, really takeaway, on this is really for big data projects, naming what you want, what you want to do with your data is actually, critical. If you can do that, you're halfway through, to the success, and, the featureizing your data by, by carefully reducing your, data dimension, from, terabytes, to maybe, megabytes. This is actually will help, so, and again, don't forget, always, you need to actually pressure test, any model you can build out of, your data. Yeah, I think.
So the next time you hear someone proclaim, I need a ton of data in order to implement machine learning, stop them and say, not so fast, not necessarily. And the Alyce team has been blessed and fortunate to work and explore several use cases here today. Xiao has described very explicitly the cases where you have as few as a single point, and how to get through that and think through that problem and not let that limit your ability to apply machine learning using techniques like simulation, etc. The next case explored a medium-sized data set that was pretty diverse, and how to get through that, maybe in a semi-supervised way, complementing that with alternate sources of information, reducing the dimensionality, etc. And in the case where you have a lot of data or big data, that's not your perfect case either. But I think it all boils down to starting with a clear business outcome. The most perfect technical model means nothing if you don't start with what business problem that you're trying to solve for. What is it that you're trying to predict, and what is the outcome you're trying to achieve? Once you get clear on that, the concept of cutting through the data as a limiter becomes moot. It allows you to creatively right-size your data and create a validation scheme that validates your approach, and have confidence that whatever way you've chosen to deal with the size of your data is relevant and exposes the value that you had entertained. So we're excited about this series, this myth-busting series, as the Alyce team. In about a month, you'll see us come back and explore the very hot topic of dashboarding. Alyce has a lot of opinions in this space, and we're going to explore why a dashboard isn't the silver bullet, and why just having a dashboard isn't enough. And if you think you've got one or two or three and you've solved your life's problems, Alyce is going to explore why that's not necessarily true. So we will get back to you and start to publicize our next webinar, which will be near April 1st.
Okay, great. Thanks, Tanya, and thank you, Xiao, and thank you, Jason, for sharing all of your thoughts and insights with our audience. So at this time, I would like to turn it to the audience, and I want to hear your questions, and I just want everyone to type their questions into that chat box, and we'll read them aloud, and then we'll answer them as we go in a live Q&A. So the first question, I'm not sure who this would be directed to. I'll let the three of you, maybe all three of you answer it. So the first question is, why do people assume that so much data is needed if in fact it is not? So I guess, to paraphrase, where did that myth come from?
I can give you a quick answer, and Gel's formulating a better answer, which will take longer. I think when AI first started, it was very much synonymous almost with big data, and big data was somewhat defined in terms of the velocity and variety of data and just the sheer size of it. And you're kind of left with the presumption, oh, I need that, then to drive these new insights that have never been had before. And while there was some truth in that, in the financial, advertising, and areas that really do have a lot of throughput data and/or exhaust data, in some other areas it was probably less true. Some of the more traditional sciences, some of the more traditional manufacturing areas, at least initially, probably wasn't a big data problem, was more of an insight problem. So, I think that may have slowed people down in terms of reformulating that just through the popular press, making AI and big data pretty much synonymous. At least that was my impression.
Yeah. I think, to add on, to Jason's point, I think, one point a lot of time, when we try to build machine learning models, we are missing the cost of collecting data. But one example I can give you, in the ag industry, where if I want to actually understand the performance of a product, I have to wait actually a year to know the answer. So presumably, in that case, you're not actually gonna get, the type of data, let's say Google or others would get through their online, shopping or their kind of, the data. So cost definitely is a factor. So, which means, for some of the problems, we will try to solve actually, or you have to actually start with a relatively smaller data set. So the other thing is, I think is really, because I'm a data scientist, I used to think, I always have high expectations that, hey, when I start for every ML project, I'm gonna get actually 10,000 data points or 100,000 data points. I think it's really the thinking that over the years I have learned is really that for different machine learning problems, we have to actually manage our expectation some way. So which means there is a human factor here. You always have to kind of bear in mind.
The only thing that I'll simply add is the concept of validation and thinking through training versus test set in a way to independently validate your approach often can lead you to thinking that you need big data in order to do that proper independent validation.
We encourage you to visit objectcomputing.com/events to keep up with all of our future webinars, including the next webinar on this topic, myth busting. And you can also reach out to us on Twitter at the handle Object Computing, or find Alyce on Twitter at Alyce.ai. Thanks everyone for joining.